Okay, today let's talk about Codeforce 2033E. First part is description. We are given a permutation of length n. That means you are given a array whose length is n and it contains a distinct number. For example, 5, 4, 3, 2, 1. And we will take this as an example many times. We can choose any two elements for this array and swap them. That means we can swap any two elements for this array. After that, we can do this operation any times, include 0. Our target is make the every elements of this array can satisfy one of the two requirements. Every elements require satisfied one of the two elements. First, we want to make it pi vi. This is a vector, that means array vi equal I. For example, that means the index is same with the elements of in this position. That means 1, 2, 3, 4, 5. The first element is 1, so the value 1 is equal with the index of this value. The second value 2, third is 3. So this can satisfy this requirement. For another kind of requirement, we can make it VVI equal I. That means actually we can make another way of this requirement. We can make G equal VI, and that means VG equal I. So we will know VI equal G and VG equal I. That means we can swap the two index of this array and make them become the element's value. This also can satisfy this requirement. That means, for example, we can take this as an example. We can swap the first two elements. That will become 2, 1, 3, 4, 5. These two elements also can satisfy this requirement because v2 equals 1 and v1 equals 2. So for this problem, what we need to do is return the minimum possible times of the operation. After that, we can transfer this array become a new array. Every element of the new array can satisfy the one of the two following requirements. What we need is return the minimum possible times. So okay, this is the description of this problem. For next part, let's talk about solution. First of all, we can check every element to determine if it already satisfied one of the following requirements. If it is, we don't need to process it. In contrast, if it's not, we can okay, this is the first thing we check if it satisfied. If it is, we don't need a process. Secondly, if it cannot satisfy the requirements, we need to do some operations. For example, 4, 5, 3, 2, 1. We can check this every element. We will know for the first, second, fourth, and fifth, these elements also didn't satisfy the requirements. But only third elements can satisfy it. So what we can do? So we need to do some swap operations to make the first, second, fourth, and fifth elements satisfy the requirements. So which pair index we need to swap. This is the key problem. Actually, for every element that didn't satisfy, for example, let's take the false as the example. First thing we can check where the false can go. That means where the false to another position that can become more elements from unaccepted to accepted. First of all, we need to check where to go. That means where 4 can go. This, I take the example, 4, 5, 3, 2, 1. First thing we will know, the fourth can go the fourth elements. That means we can swap V1 and V4. 4 is Vi, the value. That means after we swap the first element and first element, it will become 2, 5, 3, 4, 1. After this, we will know the fourth elements become, right now it can satisfy the requirement because Vi equal I. They can satisfy Vi equal I for I equal 4. So this is the first position 4 can go. This is the first position. In addition, where 4 also can go another position. Actually, for the four elements, we also can transfer 4 to the second element because the fourth element is 2. After we transfer 4 to the second element, it will become 5, 4, 3, 2, 1. In this situation, we will know we can swap the index of second element and fourth element. That means the second element and fourth elements also can satisfy the requirement. That means V4. V4 is 2 and V2 is 4, so it can satisfy this. In addition, it also satisfied VV2 equal 2. So these two elements become from unaccepted to accepted. So there are two elements, there are two positions the 4 can go. First is go the fourth element, and the second is go the second element. So right now we will know where the elements that cannot satisfy the requirement should go and make more elements become satisfied. This is the first part. That means where to go. Secondly, what we need to do is check who to come. That means which elements can come the first element and make more elements become satisfied. Because we swap to value, we need to make the elements to another position, and we will move another elements to this position. So we also made it at the requirement 5. This is 4, 5, 3, 2, 1. First of all, we can make the last elements to 4 because after we transfer this, it will become, that means we swap V1 and V4. After we do this array will become 1, 5, 3, 2, 4. After this, we will know the first elements become satisfied right now because it can satisfy vi equal I for I plus 1. Addition, we also can transfer another element to the 4. This will be, because this value is 1, so we can transfer this value is 1. So another value, another 1, and the position of value 1 is 5. So we can transfer 5 to the first position. After we transfer this, it will become 5, 4, 3, 2, 1. So the value, or the values of first and last elements is 5 and 1. It's like we swap the index of 1 and 5. That means we need to swap the first two elements, v1 and v2. That will become this array. After that, we found the first element and the last element become available because because these two elements satisfied vv5 equal 5 and vv1 equal 1. So these elements become satisfied. For this part, we will know which elements need to come this position. Second part tell us who want to come this position, and the first part tell us these elements, where these elements want to go. These two kinds of operation also can become more elements from unaccepted to accepted. So, but our target is return the minimum times. That means we want to every one operation to become more elements change from unaccepted to accepted. So the first priority, or the top priority will become if the where to go is same with who to come. If one of the value or in where to go and is same with one of the value who to come, so we can swap. The first priority is we need to swap this kinds of situation because it can become more elements change from unaccepted to accepted. This is the top priority situation we need to process. Let's take this as an example. If the force where to go for the first elements is the second elements and the fourth elements. In addition, for who to come part, the second element and last element can go the first position. So this position, the second position, is same. They are the same thing. Also want to this tell us the first priority will become swap the first two elements. After we transfer 4 to the second elements, it can solve two elements. It can solve the problem, the requirements of two elements. If we change 5 to 4, if we change the 5 become the to the first position, it also will solve the problem with 2 elements. So so the first priority will be when the where to go, one of the where to go is same as who to come. We need to first priority should be process this kind of situation. This is the first situation we need to do. Secondly, if they are not same, we should process one of go or come. That means we can process these 2 situations. They are the same priority. We can process one of them. In my code, we process the first thing where these elements can go. In addition, after we do the second operation, we need to check if there is another top priority we need to do. If there is, we should do it. If there is not, we can do the second operation one by one. So this is all about all the solution about this part. This is the strategy how we can choose the swap pair. Okay, for the next part, let's talk about complexity. For the time complexity and the space complexity, we also don't need extra. For the time complexity, we don't need extra time to solve this problem, so the time complexity will be O(n), and for space complexity, we don't need extra variable or data structure, so the space complexity is also O(n). Okay, this is all about this problem. Thanks for your watching.